Did you say you opened the final project already?
I think it's set to open during the middle of class today, but I will be opening it today for sure. But it may not be out there just at the moment. Okay. What did the old lawn chair say to the new lawn chair? Action. Any guesses? Welcome to the fold. What did they say to the guy who invented zero?
You mentioned nothing.
Yeah, thanks. What did the chef say as the water boiled away? You'll be missed. All right, so today we have a lot to cover. I'm hoping I've got everything. This requires a whole lot of setup to get it all up and running. Hopefully I didn't forget anything. So today, again, we'll be covering the SSH, we'll be covering the project, we'll be covering the SCP command, how to transfer files back and forth. We'll also be setting up your accounts on the server, so y'all will be able to set all that up here in class, which we'll kind of do at the end. And at the very, very end, I'm going to open up the project and kind of just point out a few things on that project. So lots to get through, lots that can actually go wrong, and it has one semester before. But let's get it started here. I think I got everything going. All right, so we'll be covering what an ETL is, and that will be your project, is creating an actual ETL engine is what it's called. And you'll be working with a remote system to do that. So ETL stands for extract, transform, and load right here, and kind of breaking those down. So the extraction process is just reading data from a source, could be multiple sources. Yeah.
The PowerPoint presentation.
Is it not there? Yep, it is hidden. All right, I did not upload. I think that will be the newest copy, but just let me know if you see like something looks off on that as I'm going through here. If not, I'll upload a new version of it because I apparently forgot to do that. Let's see. So transform, that is just taking the data you downloaded and then doing all kinds of manipulation. So it can be several different things that you're doing to that data, but you're trying to make that data usable in some way. And then load, that is going to be loading that information into a database. Now, here is just a list of transformations that you could do. Some would just be isolating some columns. Some could be like if you have a bunch of codes and they're all different in the data, then you're going to standardize that data to some type of single format in there that's usable. It could be taking calculated values, that's what I'm trying to get out, and then doing some calculations and creating like some kind of sum on it, sorting data, joining data, just lots of different things in here. We're not going to do these all, but you can kind of look at that list a little bit later if you want to see all of them there. Now, on your project, y'all are going to be processing a file that has a little over 1,300 lines of data, and then it's got 14 columns in there. Again, we'll use the server that'll be housed in that server. You're going to wind up downloading and then creating an ETL engine that's going to be a bash script as that driver there. And then right here, when I'm talking about each numbered step as an ETL flow or a Unix filter, what I'm trying to state to you there is there's going to be steps that are numbered in there. And oftentimes you could just I'm going to code just this step and that step alone. And then you could, in some cases, pipe to the next step. I'm going to argue that we talked about there's some downfalls to using pipe. So what I don't want to see is this huge piped program. It's going to be very hard for you to troubleshoot if you pipe it. Now, there are good use cases for pipes. Like a simple one be if you have some data, then it needs to be sorted. Now, you could create a temporary file, then call sort and use the temporary file as its input, but that's a little overkill. that would be a good scenario where you should just use a pipe and then send it to sort. If you need to do a word count, that's a good example. Just something that's going to simply alter that data, but not change it overwhelmingly. Those are good use cases for a pipe. But just limit the pipe usage. And a good rule of thumb is every single step that I have listed, that would be a good indication of kind of creating a whole new process there. So just take the output from that file, then move from step 1 to step 2, and then step 2 would take step 1's output as its input. That makes sense? All right, when it comes to this, this is kind of everything we've learned through the semester. You're going to be applying that knowledge in this ETL engine. So we need to use bash. Of course, we'll cover awk here, and it will be required for you to do some awk. And I know we haven't gotten to awk, but that's kind of near the end of the project that it's going to really require awk in there. So don't worry, we'll come back right after, you know, the spring break, and we'll cover awk that week, and you'll be good to go on that. So do not use other programming languages. And I tell this every semester, and I cannot tell you how many semesters that, and I know we all love Python, and somebody wants to complete the whole thing in Python. I do this weird thing. I actually read your code, and I know that you used Python. And so don't do it, because if you use some other language other than bash and awk, you're going to get a 0 on the entire project. No questions asked. This is not a class covering Python, Ruby, or any other programming language. It's covering bash. So here is the general overall steps of it. So you're going to transfer that file from the server. You will need to, when I say unzip it, that is whatever format that is in, you're going to have to extract that. I can go ahead and tell you it's going to be bzip. So you'll need to be able to unextract that bzip file. You're going to remove the header from the records, convert it to lowercase. Then there's like a list of gender codes, and they're all kind of different in there. So you're going to have to look at what the standard code should be for all of that, and then apply that to every single record. Then I'm going to tell you at what data is kind of bad data that's going to throw off some of our calculations at the end. And that data now needs to be taken out of the file. And then we're going to have some purchase amounts in there. So you're going to have to clean that up. In other words, like the $, take the $sign off. So that way we can do some math calculations and that won't get in the way. You're going to create a summary file from what is called the transaction file. So basically this file that you down, like all the manipulation will be held in this transaction file. Then you're going to create a separate file called the summary file from that. And you will sort that. And then you're going to create some reports. For this one, there's just going to be 2 reports, and those reports are actually going to be formatted. So you're going to be graded on not only the accuracy of your answers, but how it looks as well. And you'll have an example of how that data should look. So you'll be graded on the formatting as well. And then I did throw it in. So the graduates are going to have to do a research project, and that is Maria database, but it is bonus points if you want that for the undergrad there.
Is that just like SQL?
Yes, that's exactly what it is. And of course, right now we haven't even covered how to install software. We will get to that after awk. That'll be one of the first things, is installing software. But this is the very, very last thing that you would do anyway. So don't worry. I will show you how to install, but I'm not going to walk you through everything on the MariaDB. The database side is research. You're going to have to figure out how to do that.
So you said we'll be working on the server. Does that mean that server already has MariaDB? And then when our final version will push it?
No. Remember, we're using the server as basically a repository for information. So your script will then contact the server, download the file onto your local system, where then you are doing all the processes. So you will install MariaDB locally on your system. I have it on my system. And you need to make sure that all that can work, where it's not locked into just your account. So you need to create it in a way where when I download my system and I put in my password and I put in my database name, it's going to automatically load all that stuff in there.
Undergraduates in MariaDB?
Yes. For undergrads, it's going to be bonus. For undergrads, bonus points there. So just a graduate. All right. Now, when it comes to your program, it needs to be easy to run. It needs to report error messages or report message as its progress. So we've done that several times. What I don't want to happen is this, there's a lot of stuff that's going to take place. I don't want to hit enter and just sit there at a blank screen for a few seconds and then boom, it tells me it's done. I want to actually see, like, just a general rule of thumb is for every single question I give you, like question 1, you do that, generate some output that tells me what's going on. What that does is at any point in time that that script breaks, I actually know at what point roughly that it happened in your script. Because if I got to sit there and dig around and I can't find anything, then you're probably not going to get many points for that. I will try to get you some extra points if I can, if it does break, but if you make it really difficult, I'm not going to be spending an entire day trying to figure it out. So the more feedback you can give, the better it is for me. And then of course, error messages, you need to kind of tell me, and just think when it comes to the whole error stuff, we're keeping it pretty generic, what we've done so far. Remember your arguments, that's what I'm really looking for when it comes to the error messages. So if I put something in wrong, then it should generate a message, like for instance, the IP address. If I put a username where an IP address needs to be, then it should tell me, oh, hey, this argument, it requires an IP address here. And then of course, all that will be in there, the requirements for that. And then see, cleaning up your intermediate files. So you can, at the end of this, just automate, like if it gets done and you're going to have all these temp files, you could just clean it up. I would suggest at the end, you create a question. And that question should be like, it finished successful. Do you want to delete these temporary files? Because what I've had happen in the past before, this thing will run perfectly fine. And then at the end, I get in there and then you're going to have so many files that are expected to be filled with data. And then one of your files isn't filled with data whatsoever. And it's a simple mistake. But if you leave the temp files for me, then I can go in there and figure out, okay, I think it happened at this place. What temp files did they have? Okay, here's the temp file. Here was that data. They just maybe had a redirection error in there where it didn't get sent. So at least I can give you some partial credit. But if I don't have access to that, then I'm not going to sit here and recode your project so I can get those. Again, it will take time to complete. Start it early. Don't wait to the last minute on this. I've had people wait to the last minute. Matter of fact, here recently, I had a student that did their entire project, and at the end, they put in code to clean it up. But they wrote the code a little bit too good, and it cleaned up the entire directory. And what happens when you delete something on Linux? It's gone. So I would say back up your data before you do anything drastic. You can incrementally back this thing up, protect it, because I would say I've had 3 semesters now where students have lost their whole project completely near the end.
Are we doing this project in groups or are we doing
It'll be individual.
Is there a command in Linux that just moves it to a temp file that's like recycle bin, or would you have to make something?
You would have to make it. There is nothing, but you can create your own. If you created a recycling bin, and then if you create like a for your remove command, just create an alias that copies it first and then removes it. Then you've overwritten that RM command and you've built in your own recycling bin. And then you could then just go in and clean up that temporary directory whenever you want. Or we'll cover later, you could actually create just a, like once a month that it goes in and cleans up a directory. You can create a schedule and it will run whatever command you throw in that schedule. So
we're going over that.
Yeah, we will. All right. Again, we don't have a lot of time, so I'm going to speed through this and we'll learn more about when we do it. But just in general, we're using SSH to connect. So the client contacts the server, then the server, in this case, it says it's using a public key. Of course, if it was a password, then we would be using a password for the negotiation. But, it sends its public key. There's the negotiation that takes place between the public and private here. And then if you're approved, the client gets to log into that server. So every machine has the Open SSH toolbox pre-installed on it. So we have SSH already available to us. SSH is just a cryptographic network protocol that encrypts everything. So our communication is nice and secure between there. Now, a more secure option, which we will be using, is the SSH key. So after we first establish that SSH connection, we'll come back and we'll create those SSH keys. And then again, I will disable the password login from that server whatsoever, and we'll all be forced to use those SSH keys. Also note right here is it's used for login, but you can simply use the same command and or same command as the SSH command, and then tack on some commands at the end. And it's pretty cool. Instead of logging you in, it'll do this in the background. It'll kind of send that command to the server. And then the output, instead of going to standard out at the server, it's sent back over to your computer. So the output is literally the server, but it's going to be sent back to your local machine, a standard output. So if you just wanted to see like what's in a directory real fast, you could simply do that, and then it'll shoot back the directory information to you. Okay, here is the syntax. So we got SSH. And this right here, I did change. I don't like ID because of the fact that we use your UCA IDs. So this should say username. So I will upload that newer version that I have. So that should say your UCA username in there instead of the user ID. So whatever, in your emails, mine's Jay Corcoran, that would be my username. And then we got the literal @ symbol and then the IP address of the server. And we'll be using IP addresses. I don't map it to a name because the IP address changes all the time. In this, I actually change it. You don't have to change this. It would be common practice for you to change it because we will be using your UCA IDs as the password. So, that could be accessed by somebody else. So you might want to change that to something else. Just please make it something secure. I didn't get around to setting up password rules this time. So I'm just going to have to do a trust thing. Of course, the window is short, so it won't be too bad. And of course, if all that's successful, you'll get the prompt there from the server to put in the password that's associated with your account on the server. When we create this, it's going to generate two different keys, a public and a private key. The public ends with the .pub for pub. The private key does not have a single extension. It'll just be whatever name we give it. Of course, the public key, you can hand that out like candy if you want to, and have other people put it on the server. Then you've just got one point of entry there. Of course, it's not everything. You still would have to have an account on there, but one piece of the information there. Now, the private key, you need to protect that because if anyone gets your private key, then they have full access to your server. So you protect that thing with everything you have. Now, when we actually get on the public server, so the way that works is your public key has to be uploaded. So the public key is just a text file. You could literally just open up the public key, copy the text that's out of that, get on the server, and there's going to be a file in this .ssh directory called authorize_keys. You would paste that into there, and that is what the file gets read to verify that you can have access through that public and private key. Now, you could do it that way, but we'll see in a minute, there's a utility here. Skip through, y'all can read through that on. So here's the utility. We'll use this instead, SSH copy ID. So when you have an account on there and you create your public keys, you can simply call SSH copy ID, and then it's going to do all that for you. Rip that text and then paste it right into that authorized keys for you. And of course, here's our syntax to get that. So you just have your username, @ symbol, IP address, and of course, preceded by the SSH copy ID. This right here, not so important anymore because SSH is actually built into Windows, which is nice. Used to, you couldn't SSH from Windows, but PuTTY is still a nice kind of program to run. It comes in two forms, an installation one, or you could actually do a USB version where it just runs right off the USB. It's a software program that you can put in all of your connection information. So you can do your username, the IP address, the public private key, all that information, and then store it to just a single name. And then you just double click the name and then it connects to it. So when I worked at the hospital, we had several, I managed the switches, the routers, and we had several offsites, other clinics there. So on my laptop that I carried with me, I had PuTTY. So that way I didn't have to remember all the switches and stuff that are out there and all the different sites. I could simply just plug it up and then double click and then have access to any of the resources that I need. So I use that all the time and loved it. Now, this right here is a great chart right here for the exam. It kind of sums everything we just talked about. So authorized keys, that is where the public keys are stored. And of course, it is a text file. Its location is on the server. Now, config file, we'll talk about that in a second. We can take all of the information that we need to make a connection to the server and put it in a config file and give it a reference name, kind of like what I talked about with PuTTY. And then instead of typing SSH, my username and the IP address and remembering all that, you could simply type SSH class server, and then it'll pull all that information. You don't have to type it. Now, your two keys, by default, they're going to start with ID underscore and then whatever type of encryption that you have. And of course, this is your private. Here is the public key. And so if we'll do RSA. So ours will say ID underscore RSA in both of these places right there. Then we've got known host. Of course, all of this right here is on the client, so the local machine that we're working on. So known host is the first time that you make a connection to a server, your computers kind of balk at you and be like, hey, I don't know this server. I don't trust it. Do you trust it? So you would type the word yes, you hit enter, and then the public key from the server is then listed into known host. So therefore, now your local machine trusts the server. Doesn't mean the server trusts you, but your local machine now trusts the server, and you're allowed to make that connection, and it'll never ask you that question again. Here is the SSH right here, and you can tack on the command right there and it'll run it. Here is our config file. So there are many settings. We're just going to do a few. So the first one is you kind of have this host name, and this is where you will give it whatever name you want right there. So that's going to be the name you use to reference this information. And then you have the keyword of host name. So that would be your IP address. This would be the username that is on the server, not your local username. And then the identity file is the location of your public and private keys. So it's a little bit easier to understand. Note, this is not the actual IP address right here. That information will be in the actual project and in your lab there. So let's see right here. So this file does not exist. It is kind of like that vimrc file. It just knows to look for it. If it exists, then it uses that information. So you can't just like vim config and it be there. It's going to be a file that you create yourself. So if you just do config, and notice that everything is color coded, the camel case right here is required. So when you're typing this, it should actually all pop up in those color codes if you type it right. So we'll use /server. That is not required. You can name it whatever you want. This is just my suggestion right here. The things you have to get right is the IP address, and then the server username, and then of course the location of your RSA. Now, this right here, we're using the default. So the default location, the default name. One of the good things about this config file is, let's say you manage multiple servers. It's against best practices. You can do it if you just created one private and one public key that are associated, and then you put the same public key on all the different servers, and then you use that to connect. It will work. That's perfectly fine. A lot of people do it, but you've created a single point of failure right there by using the same one. The best practice would be you create a public and private for every single server that you have. So if you do that, then note that you can't use the defaults because it's just going to override every time. You will be prompted and it'll ask you if you want the default or do you want to create a descriptive name. So like you could do ID underscore RSA and maybe underscore class server, or I mean, any name will work. It doesn't really matter. But then you can create multiple entries in here, and then they all would point to a different IP address, a different username, and a different private key on your system there. So it's a way that you don't have to remember all that. So very, very useful. Also note right here at the bottom that this thing has to be protected. And by default, when you create this, it's not going to have 600 permissions and it will not work whatsoever. You've got to go in and give it 600. In other words, the group and other can have no access to this file for it to work correctly. Lastly, we've got SCP. This is how we transfer files back and forth. And this right here is the actual chaotic, way they represent how you actually do this, I find it atrocious. So I created this screen, which I think is a whole lot more useful. So in order to transfer a file to the server, you use SCP. This would be the local file right here. So under this, where do we assume right now this file is located? Because this is an important concept. Where is this file right now? In the current working directory. So if it's somewhere else, if it's in like some shared, I would have to say /home, /shared and so on and so forth and point to that. I don't have to be in the same directory. I just got to actually tell where it's really located on my local system. Then this is the destination. So we're taking this file, transferring it to the server. So then we put in our server information. So that's my server username, the @ the IP address, and then note, always after the server information, you put a colon. There is no spaces. It is literally the IP address, colon, and then where you want to put that, the directory on the actual server. So if I wanted to put it in my home directory, how could I shortcut that? Yep, you could just put tilde right there. Boom, it's going to put it right in your home directory right there. Of course, you could do tilde / and then some other name right there, and then it would put it in a subdirectory of your home directory right there.
Create directories if they didn't exist?
No, it will not create those directories. And now there may be, and I think there is an option. I don't think I have it listed, but I think there is an option that you can do that. Now, here's the important thing. I highlighted local to remote. And now we got remote to local. So here's where people mess up. A lot of times when you're on the server and you're like, hey, I want this file on my local machine, I need to SCP it from there. You don't want to do that. Matter of fact, you can't do that. The reason being is because we're all behind firewalls. Your local machine has a non-routable IP address. There's no way that you can know, in here how to route back to your local laptop. So the rule of thumb is don't ever be on the server when you're transferring files. You need to be on your local machine. All we got to do is change the direction here. So you'll note from remote to local, instead of specifying the local first, I'm specifying the remote information. So I have my username, @ IP address, that colon is there. Here's the location of the file that's on the remote server. Then what is the destination? Well, the destination is now changed to my local machine. So whatever, I could put tilde right here, or I could go here and just put a dot, because that represents the present working directory I'm in. So just make sure, rule of thumb, never be on the server when you're transferring files, and then understand how it's still source right here, destination. This is the same. That's source. This is destination. It's just, the source is now on the server. The destination is on my local machine.
Is that always the case with just in this UCA?
I would say it's always, and I mean, now, like when I want to transfer from server to server and both of them are on the cloud, then it doesn't matter because I know the IP address of the server and I know it is a routable IP address on the internet. So that's fine. If I do not know a routable IP address to my destination, then I just need to be on the other side and just let the network handle out that path for me. Any questions? All right, good deal. All right, so now check our time. I think we're still doing good. What do we got? 12:05. I think that's right. All right. So let's go ahead and log into our systems here. So what I'm going to do, because none of you have the SSH connection, I have the SSH connection. So I created a username and I'm just going to log into that. So I'm going to use SU, and I think I created as Test Jacob. Yep, CD. Okay, so now if I do LL, you can see I do not have a .ssh directory, so this user has no access to the server whatsoever. Now I'm going to go in here and I'm going to say, we'll split the tab. Make that a little bit larger. So I'm going to get onto the server over here, and I've already have it because now I'm under J Corker and I have that information, and this thing's in the way. So we're going to do class. At least I hope I do. I forgot to test that. I tested it in my room. Isn't this funny? Okay, no, I don't have it. Give me a second. Let me see if I backed it up here. Told you something would go wrong. There we go. So should be tar extract. Let's hope this is one that is set up. Let's see, it's reading that. Does it have the right public? Of course not. The address. Wow. Okay. I'm gonna have to go get that key information real fast, and then I'll be right back. Oh, I'm in it. All right, give me a second. I'll be right back. That was interesting. Oh, permissions problem. Just because I copied it over and didn't extract it. So we need chmod. Let's do config and all that. So we'll say 600. Oh, connected now. All right, that since we're here on that, once you set it up in class and you have that public private key, as you can see, I just took my private key from my computer in the office and then I just pasted it in here. So when you get home and you have a home computer, if you're not, or you want multiple computers, don't create a new public private key if you don't want to. You can simply do that .ssh. And of course, once I shut down the whole private key, yeah, I don't know that you would be able to be able to upload it, but actually you could work around it. But anyway, it's a little bit easier just to go ahead and paste that information on there. A lot of times what will happen is I will have students that will go home and recreate it, and they use the defaults, and then it overrides the public key on the server. And then when they come here to classroom, their connection no longer works. So just simply copy it. It'll be a little bit easier there. All right, so here, if I can, it won't let me, that'll be fine. Can y'all see that, read that? Is that enough, large enough for you? Okay, so here's the steps that we're going to use. Now, one of the things that I'm going to have to do first is I need to set up your actual information, or you're not going to be able to log in. So what I did is here I have a test roster right here, so y'all can kind of see what's taking place. If I cat that out, this is the information I get from Blackboard. So I just take your grade book and I tell it I only want the user information, and this is how it comes to me. Now, all I need to make this happen is I need Joe Bob 1 here separated with a colon and a lowercase b number with your numbers out there. So this represents your UCID. Of course, it's fake right there. And then this is a case right here where my preview account does not have a password in it, which then throws off the host script. So I had to actually code for the fact that there could be a missing password in there as well. And then so y'all can kind of see the output. So if I run sudo /1 here, and then I gave it the test roster, hit enter, going to ask him, it's going to clean up the file. Right here is the actual name of the file. So if I was to cat out that class roster file, that's what it bulls it down to right there. And the reason why I need this input is because the account, or the commands to create accounts on there, that's the format that it wants. So that's all I did, is just bulled it down to where now I can feed it in that. I'll actually pull all these scripts up later in the semester when we cover creating user accounts, so y'all can see how I scripted it, because there's no built-in script method. I had to write my own script to script it. But now y'all can see kind of how it works right here. So let's just do an ls. So I have the spring roster in here. So now let's go ahead and just remove that class import file. That's the file that was just created. Yes, I want to delete it. So now I'm going to go ahead and do that same thing again. Sudo /1 here. Go ahead and feed it in y'all's file. And then it told me that it found a blank password right there. So if I copy and paste that, you can see the preview user, it did not, it kind of got ripped out of that file. So therefore it didn't cause any issues. And now I have your file, and I broke it down like this. I wouldn't create this, I just create a single script that does all this, but it's easier to teach it if I create it in separate steps so y'all can see what's going. So now let's go ahead and do, it needs to be sudo. And then we'll feed it in the file that it created, which is that class roster. So we do that, and then now it's creating all those user accounts for us. And then it went ahead and changed all the passwords. And then if we look in, if I do @/etsy/group, you can see that everybody was in here, and everybody belongs kind of to their own group in here. There is a Linux one. It's not jumping out to me, but we're going to now add y'all to the actual Linux group in here. So I think that one's the 3, add to group. I feed in the same file again, hit enter. Now it's going to add y'all to the group. So if we go back and cat that, we should see, yeah, there it is, Linux class. Now all the users have been added to that. And the next step is, this one is if I want to delete it. And you all have probably figured out I'm a little nerd in here. So I call this shield control. It makes me think of Star Trek, and I've got to lower the shields. So I created this really corny thing right here. So I do sudo /5 shield control. I hit enter. This is actually doing a grep on a config file to find out, is password authentication on or not? And then if it is no, then it actually branches my code to ask me, well, do you want to lower the shields? I say yes. So I hit enter. Then I created that little corny thing, which pleases me quite a bit. So now the shields are lowered, and we get the little color change on there. And then it greps the file once again and tells me, okay, it verifies password authentication is now set to yes. And in the background, it actually did a source on the config file. So that way it updates it in the background. So now we have password authentication on here. And then let's get back to the instructions. So now we all have accounts on here, and I want each one of you to kind of walk through this step by step with me. So you will do SSH, and then you will do your username, and then you will plug in this IP address right here. So in my case, I have test Jacob, but on the server, I think it's actually user 88. Yours are going to match. Well, it depends on your system, what username you have, but it's okay if they match. Sometimes it's a little confusing.
Just be sure, usernames are regular school name, colon, B, and then our.
Yes, kind of your email, the first part of your email address. So mine's jcorcoran@uca.edu. So it's just J Corcoran as the username.
Is there a password?
The password is going to be your UCA ID. So that B0, but it's going to be all lowercase, not a capital B. On this part, how about I do this? I can pull it up into two separate windows. It won't let me adjust the bar right here. So that becomes problematic. So give me a second and I can do that. No problem. So now let's do this. Then I'm just going to call up another terminal. That'll give me better control there. Pop them in here. Pop that there.
Yeah.
Oh, hang on. Why are they doing that? Are y'all getting this same message?
I'm getting next close by 20, 102, 105, 101, 22.
I'm saying that it can be established and I have the options of yes, no, or fingerprint.
I'm still a step. I'm in.
I did yes.
And yes, and then I did the password.
I just got a blank screen.
Okay.
Well, yes, password.
I may have a problem here. All right. Some of you try to connect real fast.
Well, I think I'm running it and then eventually it worked.
Yeah, it works.
Okay.
Type in your bear ID. Yeah, like E0. Then you have to do E0 though.
All right. We'll try to proceed. It might have been everybody did it all at once. And like I said, this is a low cost server. It might have overwhelmed the actually CPU on it. So I've had that problem in the past, but I thought I upgraded it enough. All right. We'll try to proceed here. So it's this. Okay. Move this over and try to make this a little bit larger, and then we'll just work through step by step. Is that large enough? Okay. All right. So I am going to make my connection. So it's SSH, and I think mine is, no, it was server user 88, and then at, and I'm going to paste that in right there. Now I'm going to hit enter. And this is where it's going to ask if your local machine, does your local machine trust the server? Of course, and you can't type Y or anything. It forces you to type yes. So going to hit enter. Now you can see that it was permanently added right there to the known host list. Now it's prompted me for my password on the server. Let's see if I can remember it. Yes. All right. So if that was successful, you should kind of get this message of the day from the server here. You will also see that if your username is different, that changed, but everybody should change right this to Linux class server. So now, even though we're on our local system, we're actually on the server and not the other. All right. So we verified that we can all connect using passwords. Is someone not connected? Password denied, password denied. Levi, what are you getting?
Are you doing lowercase b or
Yeah, you can do lowercase.
Oh, it's lowercase.
Yeah, lowercase b on that, and then the number, the digits.
Yeah, okay, so, the IP address.
Okay, that worked. Yeah, 20.102.105.101.
What's the password?
The password is going to be your UCA ID. It should start with an uppercase B, but when for your password, lowercase b. You're just going to change that to a lowercase. Give it a second for everybody to catch up. Sorry, what?
You got the first digit, right? When you put a C in most systems, it is a.
Yes, yes, yours is one of those. Yeah, you would drop the first zero if you don't have the B on there. Catch there.
There's a newer release, do we upgrade it or?
No, please don't try that. One, you won't be able to. I haven't updated the thing to the new release. I just do it over the summer. So that way I don't risk something going on. All right. All right, so anybody else not connected? All right, now very, very important step for this next part is you all need to type the word exit and get off the server to finish set this up. So you should hit exit, you should get the connection is closed. Your prompt should now be whatever the name of your local machine is there. All right. Now, this step right here is I've had students in the past that I work for Axiom and they have SSH or SSH key, private, public, private keys, if I can get it all out. So if you're one of those people that you have your own private and public key already, you want to go ahead and back that up. You could do it with the tar command, or you could do it with cp-r.ssh and then just create another hidden file as a backup.
Do we need to do this if we have SSH set up for GitHub?
Yeah, if you have look right here, if we cd into .ssh in your home directory and do an ls, and if you have keys in here, so if you have keys in your .ssh directory, then you're going to need to back it up. And then you probably need to look and see if you have something called ID_RSA, because if you do, it's going to be overwritten. And if that's the case, then you would just need to create a custom name and not follow along with us, which I'll point that out when you would do that. Are you good?
Yeah, I think so. I don't have an RSA one, but I'm gonna do that.
Okay, if you don't have an RSA one, then you should be good to go, but I would back it up no matter what, either with a tar command, or you can do cp-r and you're just, creating a duplicate of that and giving it a name that's not going to be read in any config there. All right, so now at this point on your local machine, you're going to want to run SSH-keygen. And then you're going to do a -T. That's the option that specifies what type of encryption. We're going to use RSA. It is not the latest and greatest out there, but it's still pretty good. I probably need to update to the newest version, but I haven't. And then we're going to do -C, and that's just going to be a comment. So this is mainly if you have multiple public keys out there on the server, you want to be able to go to the server and know what key is what. So all it does is it's going to tag the comment at the very, very end of your public key. So that way you have a description on there. So I'm just going to put Linux class server in double quotes, all that. So -C, a space, and then the description in double quotes there. Hit enter, and then it's going to tell you it's generating the private key, and then it's going to ask, where do you want to save it? course, it already has in here the default directory and the name of the file. So if you want to change the directory, understand you still got to give it a name, but this is where you would change the name, but you need to actually put in the full path to where it goes, plus the actual name of the file on there. But if you're good with the defaults like I am, just go ahead and hit enter. Now, very, very important right here, because this causes a lot of confusion. So you just saw we connected to the server, right? And then it prompted us with the password. That password was the account on the server. That was the password that is associated with that. Now, for an extra layer of security, you can create a passphrase and understand it's just a password, but it is a password to unlock your private key. So therefore, if you lost your private key and someone else got it, they would have to know the password to get into it. So this is just an extra layer of protection. But also note that when we set this up to nothing but pass keys, we'll be able to type SSH class server, hit enter, and then it just connects. No password prompt or anything. But if you put the passphrase right here, then you're going to be prompted every single time you want to use that thing and you put in the password. Understand that it's not the password that has anything to do with the server. It's just the password that unlocks your file that you created. Now, if you don't want it, just leave it empty and hit enter. Then it's going to verify that you want a blank passphrase. Hit enter again. Then it should generate your key right here. All right. So now make sure that you're in your .ssh directory and then do an ls on it. And you should see your files there. You should have the private key and now a public key. Oh. So. All right. Now, has anybody not got those files? Okay, we're good. All right. So now that we have the public and private key, we need to upload the public key to the server. So I'm going to clear this screen right here. And then now we're going to type the SSH copy ID. So SSH-copy ID. And then we're going to have to put in the server information all over again. So mine was SRV user 88. And then I'm going to paste in and go away. Yeah. So again, mine is, it should be SSH copy ID, your username, and then the @ symbol, and then the IP address here. All right, once you're there, go ahead and hit enter. And at this point, it's telling you that, yeah, there's a key in here. And now it found that there's one key. And in order to upload it to the server, you now have to authenticate with the server. So you're going to need to put in the password of the server user account. Now, if it worked, make sure you're going to know if it worked by number of keys added is 1. That should be the message that you get back.
Can we type in our bear ID again?
Yes, that would be the server password for you. What you got?
I got a connection reset.
All right. It's probably because we're all hitting it at the same time again. Just give it a second and then try it again.
At 20.
This will be the only time that we're all hitting the server at the same time. So
when it comes to the password, is it the one you created just now or the bear ID?
it would be your bear ID, not the passphrase. Well, now hang on. I think it would be the bear ID that it hits first.
Yeah.
Okay.
It worked.
All right. Is anybody not got their key added? Not you. Anybody else? Let me know when yours is done. Did it work for you?
Yes.
Okay, we're good. All right, now, so we have that created. You're still in your local machine. Now it actually goes ahead and gives us the information right there. So if you want, you can just highlight everything in between the double quotes right there. And then you can paste it in there, or you can type it all out. And then hit enter. And then if this works, you should not have a password unless you did the passphrase. You'll be prompted with the passphrase. So I'm going to hit enter. No password was given. My keys are working. All right. Did anybody get a password prompt? You've got a password prompt.
Really?
So I learned. Man. All right, so the last thing we need to do here is we're going to create a config file. Now, again, this should be on your local machine. We're probably all connected to the server. So go ahead and exit out of the server. Do not create the config file on the server. All right, so make sure that you are now in your local machine and the .ssh directory. Again, we do an ls, there's no config file on there. So let's go ahead and do vim config. And then we'll do I for insert. We're going to do host, and I'm going to create it as class-srv. And then we'll hit tab or enter, and it actually recognizes it's going to be, and it went ahead and tabbed it for me there.
What's naming it config?
Do vim config. And then since it recognizes the config file to actually be something, you can see it color-coded host name for me. It even auto-indented there for me. And then the first thing what we're going to do is host name in camel case. has a different color code. And then of course, we're going to do our IP address. Hit enter, and then do user, and then space and your username. Again, almost did SRV user 88. And then we'll do the identity file, and then make sure each one of those, that color coding will make sure, will verify that you spelled it all correctly there. And then we can do tilde/.ssh, and then the name of your private key there. All right, once you're at that, you can save and close this file. I'm going to leave it up there for a second for everybody to catch up.
.sh file.
No, not. It needs to be in the .ssh directory, but doesn't need to be a hidden file
It's
within
just
that.
like,
It's,
just config.
yeah, just config, and that's it. Okay, so I'm going to escape, save that. Now, the first thing you need to do in here is you need to give it the proper permissions. Well, that's terrible looking right there, but permissions would be chmod 600 on the config file. You hit enter. And now you should be able to type SSH class-server. And you notice how I just typed part of class, hit tab, and it's already reading the file because it did the tab. What you got?
Oh, yeah, I connected and it was fine.
Okay, it could have been permissions were already there. I'm not sure. I didn't check. All right, so now you do that, you should be able to hit enter, and then it should connect right there using SSH class-server there. All right.
So
Any questions on that?
if you have multiple things you want to connect to, and you want to type the IP address, could you do hosts in a different name?
Yes, you would just make new host entries every time. Just type the word host.
In just now.
Sorry, what?
Could you go back up to show what you just typed in?
Oh, yeah. So right here, SSH class-server. So yeah, you would just do host and do some other unique descriptive name, and then you would do all the sub things.
So
in
that's
there.
all we need to do to log in now.
Yes, it is. Now, when it comes to your project, make sure that you know I'm creating arguments. Well, we'll cover that here in a second because I need to get to that. So one, you have a lab. In your lab, the first part of it is going to be what we just did. See if I can get to it, open it up here. So here's the IP address, and note that the IP address is referenced so many times in here. I made a note, don't use the IP address in the examples, use the IP address I have in here. If anybody knows how to create like a variable somehow within Markdown, please let me know because I've not figured any way to do that. But if you see, where's it at? Important. Do not complete this section. If you did so during class, you can skip to all the way to step 9. So you can skip all of that to step 9 where it's verify your SSH connection. And then all you're doing on here is you're connecting to the server, you're seeding into this directory that I have, and then you're touching an empty file just to prove you have right permissions to that. And then you're logging off the server, and you're using the SCP command to download from a directory on the server. And then you're going to open that file up in Vim and follow the instructions in that file. Once you complete that, you re-upload it to a different directory on the server. So that's it. So you've already got the bulk of the lab done. You just got 3 things that you have to do there. All right, now let me make sure that the project is open.
And let's do in 2024.
Let's do in 2024. Okay, I apparently didn't update that. I will update that when I get back to the office, which will be after my next class. So now both of these files are the same, but because there are different points assigned to them, I just split it up into 2 projects, but everything's the same. So it doesn't matter which one you really open right there, just different points assigned. So right here, it's worth 13% of your grade. Here's how many points for the undergrad. Here's how many points for the grad and 4+1 student. That's 200. I tell you in here, I don't mind you talking to one another, but don't copy off of one another. This is your work and your work alone. If I find copied work, which again, this is a huge project, it's going to be pretty obvious if you copied some work there, that's going to be a 0 and it's 13% of your grade. So don't do it. I included a README. So the README needs to be just, it could be very simple. I just want to know how you ran it. So if you put an example in there, that'll work. I would like a little bit more effort on it, but at least an example. So if you didn't follow something exactly how it was supposed to be, I have an example of at least how you got it running in there. So that way I can kind of alter my stuff, because I'm just going to have a script that has all the arguments, and my script's just going to call your script in there, and I'm just going to do it over and over that way. Needs to be an automated bash script. In other words, there should be no fancy user interfaces. So if I run it and then it pops up, hey, what's the IP address of the server? What's the username you want? No, don't do that to me. There's no way for me to verify any of that information within your script. And it's going to cause me to sit there and do that. And it just takes a lot of time. I want arguments. So that way my script has all the arguments and just plugs it into your script. So here is remote server. So that's the IP address. That should be your first argument. The username that is on the server, second argument, and the full path to the actual file on the server. So this is going to be the path to the file that you're downloading. So it'll be the full path plus the actual name on there. And then, of course, if you're doing the SQL side, you have to include these 2 arguments in there as well. So again, also don't like section it off and create 3 different scripts and be like, okay, to transfer it, you call this script. And then once it's transferred, then you run this script and supply these arguments. No, I'm not going to do that. I told you the arguments, what they should be. And I should be able to run etl.sh and pass in 3 arguments, hit enter, and this script runs from the beginning to the end. No other interaction from me whatsoever. I encourage you to test your script, test it with bad arguments in there, because again, there should be feedback every time something is messed up. So you need to test it with bad arguments in there. Here is the actual file that you have, the name of it. I think this part's really important. I tell you should preserve the original source file. That's one of the kind of the Linux practice. When you download that Mox mix, you should preserve it as is. I tell you to create a transaction file. So your first alteration should therefore be change the name to the transaction.csv. I think that's the name of it. See, the file name and the source file can be different. Okay, so I'm telling you right here that I'm not going to use this file name to grade. Matter of fact, it's in a completely different directory. So yours, if you hard code the file path on the server, so if I just run it and then there's a hard code that says /shared or /home/shared /mix, whatever, and then my file's in a completely different place and it's going to be named something completely different. You're going to have to code for those variables that the path and the file name is going to be different. Right here, you don't have to code for different file types as far as the source file. It is going to be a CSV file every time, so you don't have to do any checks. And I'm not going to mix up the compression, so you don't have to go through and test if it's a gzip file or a bzip or a tar file. I'm just telling you it's going to be a bzip2 file, so that'll kind of cut down your work there. And then, of course, I got each single step labeled throughout here. You can see all the file names at different points. I kind of have it in a little gray box for you, so it really pops there. And then step 11. So right here, that's your 2 kind of reports that are going to be formatted. And then here is kind of the graduate and 4+1 requirement right there. So if you're not doing that, then you just go ahead and skip down here to 12. And then I'm literally telling you, after executing, you should have the exceptions, the summary, the transaction, the purchase report. Yeah, there's the transaction. So the transactions report, the purchase report, and the transaction CSV. That is the files I'm going to be grading, plus your script. Here I'm telling you about the README file, just reminding you about that. Comments right here. And then let's see, here I'm giving you suggestions about maybe running a few examples, looking for some errors that can happen. Here I'm telling you all the currency needs to be in a 2 decimal point format. I give you the example, so that's all the currency throughout the whole entire thing. And then here, I am giving you the 2 reports. This is the first 7 lines of that report. This is the real answers. So you can literally grade the first few lines to see if you're on the right track. And then at the end here, I tell you, submit these files only. So it should be the readme.txt and the etl.sh. I do not want to see these files because I'm going to run your script. I want to make sure your script actually generates these files. So if you leave them in there, then that means I got to go through the process of removing all of those files to make sure that they're not just, fake files with the answers in them. So these are the only 2 that should be in there. Now, I want to point out, some of you like to actually create an ETL and then create a folder with your scripts in it. If you do that, that's fine. And what that would mean is your etl.sh is calling other scripts from it. It makes it a little bit more difficult for me to grade, but it makes a really clean and pretty script. And a lot of people like to do that, kind of just separate where there's a separate script kind of doing everything. And I'm okay with that, so long as you have the ETL as the main driver calling all of those separate scripts. I will not call the separate scripts in the folder. Again, I should just run it once and do its thing. All right, any questions?
I don't see this.
It's posted, let's see, I thought it was. So it should be in project folder, semester project, and then you should have those 2 in there. Has anybody else seen it? No. Let me go back. Semester project, online classroom. Maybe the root of it. Yeah, sorry. Make available. All right. And I will double check the, should be a help refresh. Is it there now?
Yeah.
Okay. And I will double check those due dates. It should be due the very, very last day of class. Let me stop this.